Hi, this is Clay from OpenC3, and today we'll be connecting the rest of the Arduino Sensor Kit sensors to Cosmos. Let's get started. All the code I'll be using for today's demo is available at OpenC3 COSMOS Arduino Sensor Kit GitHub repo. Feel free to clone this repo and use it however you wish. That'll probably be the best way and fastest way to get you all going on this Arduino and Cosmos integration. So if you followed our previous videos, you have a sense of basically all the telemetry and command setups that we've had here. But I'm going to go ahead and just kind of quickly go over some of the new additions that we've added. I've renamed our target to be Sensor Kit. We are now connecting to basically every other sensor that's available on this kit. So the target is now Sensor Kit. We are still connected to the BMP280 barometric pressure sensor. And I also added these two right here, which I'll go over. But effectively, the first one, we have limits now enabled, which means we're setting the parameters for what is considered nominal operational temperatures and what is considered maybe dangerous temperatures. I've also connected to the accelerometer, the DHT20 sensor, which is the humidity and temperature sensor. The temperature sensor, I also have the same limit response, which we'll show more later. And I also connected to the sound sensor, which basically collects sound readings. For our temperature limits response, basically what we have here is if we detect high, let's say red high, very, very high temperatures, it's going to trigger the buzzer on our sensor kit. And if we detect yellow high, as in kind of warning levels, it'll trigger the LED light. When greens are triggered, that's going to actually stop the buzzer and stop the LED so that everything's back in operational temperatures. For our command definitions, we have two. So we have the previous one, which is setting the LED to turn it on and off. We have added here a sync pattern. This sync pattern is just 0x11, so I think 17 in decimal, as well as an ID so that we can identify this command from the other commands. And then the second command is to trigger the buzzer. Again, we have the same sync pattern and the ID of 2 so that we know that this is a buzzer trigger and not the LED trigger. And basically just 1 or 0 to turn it on and off. And I've also added a variety of screens. So in this repo under screens, you'll see all these different text files, but all these will define screens and graphs that we can use to better visualize all our data. So going over some of our Arduino code changes, we now have more sensors. So we have the BMP280, accelerometer, DHT20, and sound just have different IDs. And yeah, so in our setup code, we're starting the serial port with baud rate of 9600. We start the pressure sensor, accelerometer, environment, which I believe is the humidity sensor, setting up the LED and buzzers sensors. We have a variety of payloads here, so it's very similar to that telemetry packets we showed earlier with the IDs and the various attributes that we are adding on here. And I have 4 sets of telemetry aggregations. So at the very bottom on the loop, we are sending BMP telemetry, accelerometer telemetry, DHT telemetry, and sound telemetry. All those details are available in the code, and it's actually pretty much from the example code that Arduino provides for these sensor kits. So nothing too crazy going on there. But yeah, as an example for this DHT telemetry sensor, we grab the temperature and humidity, construct our payload. We will create a buffer array with the appropriate amount of memory size. And we are adding the sync pattern, the length of the packet, and the actual data from the packet. And then we write that out to our serial port. For our receiving commands, we're looking for at least 3 bytes of data. So both our commands for this situation, it's going to be the trigger for the buzzer and the trigger for the LED are both 3 bytes. We have the sync pattern, we have the ID of the command, and then we have 0 or 1. So we just have 3 bytes for that. We're looking for the sync pattern. So if we have the sync pattern, then we know that the next 2 are going to be the command ID and the argument. And then we just have some basic code here of hey, if we receive our, one ID, then we know that we need to turn on or off the LED. And if we have the 2 ID, then we are turning on and off our buzzer. We're going to take a quick note of our USB port here. So right now I have dev CU USB modem 21201. So just take a quick note of that. Yours will likely differ from mine. So just take a quick note of what your port is. And then we're going to open up our terminal, and similar to in the previous video, we're just going to use the OpenC3 CLI command to open up the bridge to connect our serial port and pass it on to our Docker container. So I'm going to start that, and that'll just kick off. Next, I will open Cosmos, and here we see that our sensor kit is connected. You are able to connect and install your plugin via the admin console here. And once it's connected, you'll notice that if you go to the Telem packets, we are receiving plenty of packets. So every second it's sending 1 packet per each of these. So we're receiving many here. And yeah, so let's take a quick look at those screens that we set up. So if we hit Telemetry Viewer, all the different screens that we define in those text files are displayed here. One thing that's interesting here is the temperature. So we set those limits. So we set the different limits of what is considered red, what is considered yellow, what is considered operational. Right now we're hovering at 22 degrees. Both the BMP and the DHT sensors have temperature data. So they have slightly different temperatures reporting, but kind of within 0.4 degrees Celsius of each other. So we're considering that as operational. And yeah, so we also have the noise level data that's getting presented here. We have the accelerometer. So if I pick up my Arduino here and start sort of moving it, so if I'm moving this around, you'll notice that accelerometer have a lot of feedback. And we have the noise meter there. So if I make a big noise, make a big continuous noise, you'll see that noise level really go up. Great. But the big thing here is that we set up those limit monitors. So we have our Arduino here, and then we have the LED and buzzer. What I'm going to do now is I'm going to grab this hair dryer and warm up the sensors from a distance so I don't damage anything. So brace yourselves here. And you'll see those temperatures really start skyrocketing. So I'm going to do that one more time. Yeah, and then there's that buzzer sound going off now. And the buzzer sound is because that red limit was met, and we are now like really hearing, yeah, the buzzer's going on. It might be hard to hear from the, yeah, but that limit response triggered that alarm, so we're able to kind of have this like abort script. And now to start cooling it, I'm going to turn on my fan and just put it next to my fan here, just to try to cool it a little bit. So you'll see those temperature by sensor graph start to dip. The yellow limit has been hit, so we'll, oh, and we're back. Yeah, there's that yellow yellow light, and the LED is turned on. All right, and now it's back to green. We've cooled it down enough, and the buzzer has now gone off, and the LED has also turned off. So kind of a really cool way to be able to see all the different sensors working together and setting up those limit monitors so that we can always have operational, and set up some scripts so that like maybe there is an abort when certain temperatures are reached and whatnot. If you go to the limits monitor, from here, same thing will happen. So I'm gonna use the hair dryer again and heat this up from a distance. Yeah, so as that warms up and the yellow limit was hit, the LED was turned on for a little bit, and you'll see those limit events trigger. I'm gonna heat it up one more time. Yeah, so the red was hit. I hear the buzzer. And yeah, and then all those limit events are also recorded here. The last thing I wanted to showcase here is the command sender. So from the command sender, we can select the set LED packet, just change this to state of 1 to turn it on. And then we'll see that command gets sent out, and we can also turn it off. If we use the trigger buzzer and set that to 1, we'll hear that buzzer, and we can just turn it off also. So kind of in the limits monitoring, we're using these commands to turn it on and off, and the Arduino code is able to interpret that and react on it accordingly. So that was a quick demo of integrating all the various sensors on our Arduino Sensor Kit and adding some logic, some limit responses, some monitoring, some sending commands, receiving telemetry, setting up our screens. So yeah, hope you enjoyed. Hope this was valuable and useful to you all. If you have any other questions or suggestions, please feel free to reach us out on GitHub or on LinkedIn, or we're very easy to reach. So, but thank you all for watching, and we'll see you next time.